In this lesson, we're going to go over how we can find the average value of a function. When we're calculating the average value of anything, we add up all of the values and then divide by the number of values. If we have a continuous function, the sum of all the values over a specific interval from a to b is going to be the integral from a to b of f of x dx. So by taking the integral of something, we have the sum of all the values in between the endpoints. If we want to find the average value of a function on an interval, we're going to have 1 over b minus a times the integral from a to b of f of x dx. So basically what we're doing here is just finding the average. We're taking the integral, which is the sum of all the values between the endpoints, and then we're dividing by the difference of those endpoints. So let's look at this example. So find the average value of the function f of x equals 1 plus x squared on the interval from -1 to 2. So the first thing here is we're going to figure out the average value formula that we're going to use, right? So that's just going to be 1 over b minus a times the integral from a to b of f of x dx. So in my interval here from -1 to 2, -1 is my a and 2 is my b. So if I'm doing b minus a, what I'm really going to be doing here is 2 minus a -1, so 2 plus 1, so I get 3. So we'll have 1 over 3 times the integral from -1 to 2 of 1 plus x squared dx. And then from here, this is pretty much everything that we've already done. So the 1/3 is going to stay on the outside, that's our constant. And then we're going to take the antiderivative of what's inside. So we're going to get x plus 1/3 x cubed. And then we're going to evaluate that from -1 to 2. So if we do that, we're going to, and I'll just write that step out here. So at least show that you're plugging in the values. So we're going to get 2 plus 1 over 3 times 2 cubed minus -1 plus 1/3 times -1/3. And then if we simplify this correctly, we should end up getting 2 as our answer. Okay, so we should be okay with finding the antiderivative and solving from there. The new thing is just this setup, which is pretty similar to things we've already done. Let's look at another one. So find the average value of the function sine of x between 0 and pi. So 0 and pi are our interval. So we have a for 0 and b is pi. So 1 over b minus a, pi minus 0 is pi, times the integral from 0 to pi of sine of x dx. So I'm going to again keep that 1 over pi on the outside since that's my constant. I'm going to take the antiderivative of sine x, which is negative cosine x, and I'm going to evaluate that from 0 to pi. Again, we can keep this 1 over pi on the outside, and I'm going to have negative cosine of pi minus a negative, so plus cosine of 0, and this will give us 2 over pi. All right, we'll look at one more. So again, find the average value. So our interval is -1 to 1, so we're going to do 1 over 1 minus a -1, so that becomes 1 plus 1, which is 2. The integral between -1 to 1, and then our function, we have x squared over x cubed plus 3 squared, and then dx. So here we're going to have to use u substitution. So our u is going to be our innermost function, which is x cubed plus 3. Our du is going to be the derivative of that, which would be 3x squared dx. And we can see that we have an x squared dx, but we don't have that 3, and that's fine. We're just going to divide out the 3, so we're going to basically pull out a 1/3. Now notice that we already have a 1/2 on the outside, so we're going to keep that 1/2, and then we're also going to pull out that 1/3, so those two are going to get multiplied together. Because I'm going to use u substitution, I am going to change the bounds. So my limits of integration, if I have them right now in terms of x, when x is -1, u is going to equal -1 cubed plus 3, which is going to be 2. When x is equal to +1, u is going to be 1 cubed plus 3, which is 4. So we're going to go from 2 to 4. And now we have 1 over u squared du. So I'm going to multiply 1/2 times 1/3, so I'm going to get 1/6. And then if I take the antiderivative of 1 over u squared, or u to the -2, that's going to give me -1 over u, and I'm evaluating that between 2 and 4. So again, I'll keep this 1/6 on the outside, and I basically have -1/4 minus a negative, so I'm going to add 1/2. And then this is going to simplify to give us 1 over 24, if done correctly. Okay, so another part of average value, what we're going to look at is a kind of real-world problem. So in this case, this picture is a picture of temperature. So T of t is the temperature at time t, and we might wonder, is there a specific time when the temperature is the same as the average temperature? So the blue graph is the temperature graph. The red line is the average temperature, and it's a constant. So once we get an answer for the average temperature, that's what it is. So we can see from this graph that they intersect twice. They intersect right here at 12, and they intersect again at 24. So at like noon and midnight, the average temperature, which is the red line, is going to be the same temperature as the actual temperature. So in general, is there a number c at which the value of a function f is exactly equal to the average value of the function? So basically, does f of c equal f average ever? Okay, so this kind of brings us back to one of the theorems we talked about earlier, which was the mean value theorem. So the mean value theorem for integrals is stating that if f is continuous, and this is key here, f has to be continuous on this interval, then there exists a number c within the interval such that f of c is equal to the average value. Okay, so let's look at this example. Now this example we saw already in the beginning, so let me just go back to this real quick. This is the same problem. We found the average value of 1 plus x squared on the interval from -1 to 2. And we got that our answer was 2, the average value. So when I go back to this problem, okay, given a continuous function, which is that, on the interval that, find the value or values c in which the mean value theorem for integrals is true. So we already know what the average value is for this function. So f average is equal to 2. And I'm just going to write that that's from the previous problem. So we already solved that. If we needed to solve it, we could, right? But we already did this one, so let's not do it again. So f of c is equal to f average. So for f of c, all we're going to do is take this function, f of x, and plug in c instead of x. So we're going to have 1 plus c squared, and that's going to equal the average value, which is 2. And then we're just going to solve for c. So c squared is going to equal 1. And then when I take the square root, c is going to equal plus or minus 1. So there are two answers here. So at 1 and at -1, the value of the function is going to equal the average value. So let's look at the graph of this. So we can see here, this red line, that's our average value, that's 2. We can see this blue curve, that's our function, and they intersect at -1 and at +1. So that is when the function and the average value are going to be equal. Okay, and then we're just going to look at an AP question. So here is a non-calculator AP question. So the inside of a funnel of height 10 inches has circular cross sections as shown in the figure above. Oops, there's no figure above, but that's okay, we don't need it. At height h, the radius of the funnel is given by this function, and h is between 0 and 10. And then the units are inches. Find the average value of the radius of the funnel. So we're going to use our average value. So it's 1 over the b minus a, so our interval is 0 to 10, so 1 over 10, times the integral from 0 to 10 of our r function, which is 1 over 20 times 3 plus h squared dh, because h is the variable we're using. Now here we see 1 over 20 is a constant, so I'm going to pull that outside with the 1 over 10. So I'm going to multiply them together. If I take the antiderivative of 3 plus h squared dh, this is going to give me 3h plus 1/3 h cubed. And I'm evaluating that between 0 and 10. So right now we've got 1 over 200 on the outside. And then what I'm going to do is just plug in my 10 for h here first. So plus 1/3 times 10 cubed. And then put a little bracket there. Minus, when I plug in 0, I get just 0 for all that. Okay, so if we solve this correctly, we should end up with 109 over 60. And because they told us the units are in inches, we have to make sure we put inches as our unit. And that would be our answer. Okay, and just one other thing I just want you guys to be careful of. Not every question that uses the word average will be an average value question. So here in this problem, we've got these grass clippings that are placed in a bin and they decompose, and we're in the interval from 0 to 30. The amount of grass clippings remaining in the bin is modeled by A of t equals this, where A of t is measured in pounds and t is measured in days. Find the average rate of change of A of t over the interval from 0 to 30. Okay, now notice this does not say average value. If it's a question where you have to use the average value, as in taking the integral and dividing it by the difference of the endpoints, the question will say average value. In this case, it's saying average rate of change. Now, if we remember, rate of change is the derivative. It's basically our slope. So just be careful of the two things. If you see average, it doesn't necessarily mean the same thing each time. Average value and average rate of change are two different things. So even though this is not necessarily part of this lesson of average value, let's just go over average rate of change again. So that's just basically change in y over change in x. So we're going to do a of 30 minus a of 0 over 30 minus 0. So if I plug in 30 in for the t in my a of t function, that's going to give me 0.783. If I plug in 0, that's going to give me 6.687. And then 30 minus 0 is just 30. So if I calculate this, I end up with, I don't know what that was that I'm drawing here, nothing, just need an equal sign, negative 0.197. So just be careful of the wording. It needs to say average value if you're using average value. If it's average rate of change, you're going to do this.